In this video, we'll talk about an important concept in logic called argument. Specifically, we're going to talk about what an argument is, how to represent an argument, and what are the rules we're going to use to prove an argument to be valid. What is an argument? An argument is a sequence of propositions in which the conjunction of the initial propositions together implies the final proposition. Based on this definition, we can know that an argument is not just any sequence of propositions. Propositions are not just arbitrary independent propositions. There is some relation among those propositions. Next, let's see some examples. The first one is, if George Washington was the first president of the United States, then John Adams was the first vice president. George Washington was the first president of the United States. Therefore, John Adams was the first vice president. In this example, there are in total 1, 2, 3 propositions. And the first two propositions together imply the last proposition. Second example, if Martina is the author of the book, then the book is fiction. That's proposition 1. Proposition 2, but the book is nonfiction. And these two together imply that, therefore, Martina is not the author. Last example, the dog has a shiny coat and loves to bark. Consequently, the dog loves to bark. This argument only has 2 propositions. The first proposition implies the second one. Next, let's see how we can represent any argument. Because we know, by definition, the initial propositions together implies the final proposition. Therefore, we can write it as an implication, where P1, P2 through Pn represent the initial propositions. And we know those propositions together is called hypothesis for implication. And for argument, we call each of these propositions premise. The P1, P2 through Pn are n premises for this argument. And here Q, which represents the last proposition, is called the conclusion of this argument. So that's the same term for implication. Now, let's go back to the 3 examples we just saw and see how we can represent them using those notations. So that's the first one. I'm not going to repeat it again. But here, in order to represent it, we need to identify the propositions we need to represent. So we're going to use A to represent George Washington was the first president of the United States. And let B note John Adams was the first vice president. And we use this one to represent this argument, because the first proposition, this if then, can be represented by A implies B. So this is the representation of the whole argument. Second one, let's first try to identify how many propositions we need. So we have Martina is the author of the book is fiction. And this one, we don't need to introduce another letter to represent it, because this proposition is basically the negation of this proposition. Therefore, we actually only need to introduce 2 letters. Let A represent Martina is the author of the book, B to represent the book is fiction. You can pause the video and write down the representation yourself first. The correct representation is this one. I hope you get it right. Third one. This one is simple. We only need to use 2 letters. We use A to represent the dog has a shiny coat. Use B to represent the dog loves to bark. Then this argument can be represented by A and B implies B. Now we know what an argument is and how to represent an argument. But when you try to argue with someone, you have to make sure the argument makes sense. You cannot just talk about nonsense. So in logic, how do we know an argument makes sense? We introduce the next concept, valid argument. We say an argument is valid if whenever the premises are all true, the conclusion must also be true. But now the question is, how can we prove an argument to be valid? We cannot use the truth table anymore, because the truth table only tells you the relation between the truth value of the whole argument and the truth values of the small propositions. So what can we do? In order to prove an argument to be valid, we are going to introduce 5 inference rules, which we can use to prove argument to be valid. The first rule is, if P is true and P implies Q is true, then we can imply Q must be true. The example is the George Washington example. Second rule, if P implies Q is true and not Q is true, we can imply not P is true. The example is the Martina example. Third rule, if P is true and Q is true, P and Q must be true. This is very straightforward. The example is, Paul is a good swimmer. Paul is a good runner. Therefore, Paul is a good swimmer and a good runner. Fourth one, if P and Q is true, we can imply P must be true. Last one, if P is true, we can imply P or Q is true. Here, Q can be any proposition. And the last one is the most interesting one, because we can imply from P is true to P or anything is true. So now we learned all the 5 rules we can use for us to inference a conclusion from a given set of premises. So now we should be ready to argue. Next, I'm going to show you 3 examples. Each example consists of a number of premises. So I would ask you, what can you conclude from the given premises? This is the first example. If the car was involved in the hit and run accident, then the paint would be chipped. But the paint is not chipped. What can you conclude? You can pause the video and think about it. All right? The conclusion is, the car was not involved in the hit and run accident. How can we come to this conclusion? We first represent the premises using some letters. Here, this one, let's denote it by P. And this one, let's denote it by Q. And for this one, again, we don't need to introduce another letter because this one is just not Q. Okay? Then, to summarize, for the premise, you have P implies Q, and another premise is not Q. And if you still remember those 5 inference rules, if not, you can go back to check the video. If you remember the inference rules, that's exactly the premises for the second rule, which is, if P implies Q is true and not Q is true, we can imply not P is true. which is the car was not involved in the hit and run accident. Second example, if the bill was sent today, then you will be paid tomorrow. You will be paid tomorrow. Based on these two premises or propositions, what can you conclude? You can pause the video and think about it. All right? So what can you conclude? Any conclusion? Can you conclude the bill was sent today? Can you conclude the bill was not sent today? Actually, you cannot conclude any meaningful proposition. Last one. What can you conclude? Again, you can pause the video and give it some thoughts. Okay, the conclusion based on these three premises is the program has a bug. So next, I'm going to show you how we can use the inference rules we learned previously to come to this conclusion. In order to do that, we first need to decide how many letters we should use to represent those premises. This premise, let's use P. For this one, let's use Q. This one is just P. For this is a new proposition. Let's use R. And this one, it's not Q. And the conclusion is R. To summarize, the premises we have are P implies Q, P or R, and last one, not Q. From the first example, and also the second inference rule, we know that combining these two, we can imply not P. And now it seems like we get stuck. How should we proceed? Remember, we can still use the equivalence laws we learned previously. Therefore, we need to transform the second premise into a different form. But what form should we transform it into? Now, if you go back and check the 5 inference rules, 2 of them have implication in it. So let's try to transform this OR into an implication. Which law should we use? The implication law. But to do that, we need one more step. So P or R is equivalent to not P or R. Why? Because we can apply double negation law on P. And then this is equivalent to not P implies R. Then by the first inference rule, if this is true and not P is true, we can imply R is true, which is our conclusion. So far, we have been using inference rules to infer a conclusion given a number of premises. In the next video, we are going to see how we can use those inference rules to prove an argument to be valid.